So yeah, hello everyone. Welcome you all for the post-contest discussion of Codeforces Round 963 Div 2. So let's start with the discussion. The first problem is the name of the question is question marks. So let's go through the problem statement. Tim is doing a test containing 4n questions. Each question has 4 options A, B, C, and D. Now for each option there are exactly n correct answers corresponding to that option. Meaning, if there are n questions with answer A, there are n questions with answer B, there are n questions with answer C, and there are n questions with answer D. For each question, what Tim did is he wrote his answer on the answer sheet. And if he could not figure out what the answer is, if he could not figure out the answer, what he did is he would leave a question mark for that question. So you are given his answer sheet of 14 characters. So what is the maximum number of correct answers Tim can get? So the question is that yeah. So you are given some value n, and they have told you that in total you have 4n questions. Okay. So now there are 4 options A, B, C, and D. Now there are n questions for which answer A. Kindly keep yourself muted, please. Now there are n options for which A is the correct answer. There are n questions for which option A is correct answer. There are n questions for which option B is correct answer. There are n questions for which option C is correct answer, and there are n questions for which option D is the correct answer. This is something that is given to you. There are 4n questions. Now, additionally, what they have given is they have given you a string that tells you that in what order like Tim has answered the questions. So, like let's suppose I take up this string. If the value of n is 2, so there will be in total 8 questions. So they have given you what Tim has answered. So let's suppose they give you something like this. Let's suppose the value of n is 2.
Excuse me, sir.
Yes.
Can you please repeat one more time from the A options? Yeah, you're explaining the question from A, please.
Okay. So it is given that there are total of 4n questions. The value of n is given to you, and there are n questions for which option A is the correct answer. There are n questions for which option B is correct answer. There are n questions for which option C is correct answer, and there are n questions for which option D is correct answer. Okay. Now let's suppose, for example, and now what is given to you? There is given a string to you. Let's suppose the value of n is 2. This means that in total you will have 8 answers. That is basically 8 questions, so 8 answers. So let's suppose Tim answers in this something like this: A, B, A, question mark, C, D, A. Tim answers something like this. There are total of 8 answers. No. Okay. So now there are total of 8 answers to 8 questions that Tim has answered. Now the question in front of you all is that just tell that what is the maximum number of answers that can be correct. This is the question for you all. So just try to tell me. As in this particular string, you can see
स्विगी पे ट्रैक नहीं कर पाएंगे.
I am muting everyone who are unmuted right now, and they will not be able to unmute themselves now further in the contest, further in the recording. So I am muting them. Yeah. So maximum number of answers that can be correct. That is the question in front of you all. Now just try to tell me. If Tim has, as looking at the string, what you can see that there are 3 questions. There are 3 questions for which Tim answered option A. But what you know is if the value of n is 2, so the maximum number of questions that can contain option A, that can contain their answer as option A is n, that is 2. So the ones that he have marked option A, from them, can I say that there can be maximum of 2 correct answers? Can I say that? Now again,
Yes, sir.
the options that he has marked B, there are for one question he has marked option as B, and I know the maximum 2 questions can contain answer B. So yeah, we can take this value 1. So our number of correct answers increases by 1. Similarly for C, just look that he has marked that there is one question for which correct answer is C, and at max you can have 2 questions of which correct answer is C. So yeah, we can the maximum possible correct answers from this option C is also 1. And similarly for option D, you will get 1. So in total, you can say the maximum number of correct answers looking at this particular string is 5. Let's suppose if anyone didn't get by this string, let me take one more example. If I let's suppose have the value of n as 3, and I have been given string something like this: B D C A B question mark D C A B 3 3 3 3. Okay. So in total, you will be given the answers to 12 questions. Now, how many questions are there for which option A is marked as correct answer? 1, 2, 3, 4. 4. How many questions are there for which B is marked as correct answer? 1, 2, 3. How many questions are there for which C is marked as correct answer? 1, 2. And how many questions are there for which D is marked as correct answer? 1, 2. And there is one question of which he has not marked anything. Okay. So now if I put forward a question that how many maximum possible correct answers can be. So there are 4 questions for which he marked that, okay, for them the correct answer is A. But I know that there can be
क्या
maximum 3 questions for which the correct answer
हाँ
can be
करिए ना आज पढ़ाई करिए
A, right? So what I will do is I will just from here I will take the value 3. That okay, there can be, since there can be maximum of 3 questions for which the correct option can be A, so I took 3 from it. Similarly for B, he marked 3 questions for which the correct answer is B, and we know that yeah, we can have 3 questions for which correct answer is B, so we took 3 from it. Similarly for C, we know that there can be 3 questions at max for which correct option is C, and for 2 questions he has marked correct answers as C, so we can take 2. Similarly for D, we can take 2. Therefore, the maximum number of correct answers from this possible answer set is 6 plus 2, 8 plus 2, 10. So that is the logic to this question. Yeah. So if I now jump to the implementation part, so there are multiple ways of implementation. It completely depends on you on how you want to implement. If someone is here who don't know how to use maps, so they can easily maintain a 4 count 1, count 2, count 3, count 4 for number of A's, number of B's, number of C's, number of D's, and similarly do by that. What over here I have done is I have maintained a map for storing the count of every character. So first of all, I took input of n, then took the input of string s, then made one map, character comma int map, and for all the characters in the string, I simply incremented the count of every character. So basically now I am using this map to store frequency of each and every character. So I initialized my answer to 0. Now for option A, from option A, what will be added to my answer? Mean of n comma mp of A. That is, if mp of A, that is the frequency of A, exceeds the value n, so the maximum correct solution from them will be n. And if it does not exceed the value n, so how much is the value of frequency of A, that will get added to my answer. Similarly for option B, option C, and option D. Once you are done with this, simply print out the answer and you are good to go. Is it clear?
Yes.
Okay. Okay. So let's jump on to the second question. So yeah, the name of the question is parity and sum. Let's go to the problem statement. Given an array A of n positive integers, in one operation you can pick any pair of indexes I and j, I comma j, such that AI and AJ have distinct parity. What do we mean by parity? Like odd numbers, all odd numbers are of same parity, all even numbers are of same parity. So like by distinct parity we mean is one number we are taking is odd and the other number we are taking is even. Okay. So we can choose any AI and AJ that are having the distinct parity. Then we can replace the smaller one with the sum of them. So if AI is less than AJ, you will replace AI with AI plus AJ. Otherwise, you will replace AJ with AI plus AJ. Okay. So you need to find out the minimum number of operations needed to make all elements of the array of the same parity. So
I have
let's
one doubt
understand
in
what
this question.
I have
So
not
like,
explained it actually. Can I
okay,
explain it before?
yeah, sure.
Like, what is your doubt?
So like the second statement says that otherwise. So does that otherwise mean AJ is less than equals to, or like here
Can it
if
be equal?
AI
Can it be equal? I am talking of two numbers of distinct parity. That is, one is even, one
okay.
is odd. So they can't be equal, right? Okay. So if I am given an array A of size n, that is, I have A1, A2, A3, up to AN numbers, and I am told that I can take any two numbers AI and AJ such that these two numbers have different parity. So when I talk of different parities, so what I am going to do, one number will be odd, one number will be odd, and other will be definitely even. That's the only case I have. And now what I am going to do is to my AI, let's suppose AI is smaller than AJ. If this is the case, so my AI will become AI plus AJ, else my AJ will become AI plus AJ. This is something that I am doing. And by this, I want to make all the numbers of the same parity. So how can I do that? So one thing is very much clear that, okay, when we are talking of two numbers of different parity, I have two numbers AI and AJ. I am telling that, okay, one of these numbers is odd, one of these numbers is even. And whenever I am doing this addition operation, I am doing on some smaller number. Let's suppose I add AI to AJ or AJ to AI, whatever I do. The final result will be, that I will have, like if I am adding an even number to this odd number, this number will still remain odd and this number will remain even. And if I am adding this odd number to this even number, this odd number to this even number, both of the numbers will get turned to odd. So in both the cases, if you observe one thing, if I am talking of something like this, that okay, at the end,
Tomorrow total day for me.
I want to make all the numbers of the same
Tomorrow
parity.
total day.
If I want to make all the numbers of the same parity, if I am thinking something like this, so the first thing that comes to my mind is that, okay, that same parity, that same parity can be of odd numbers. Why I'm talking like this? Because let's suppose I have three numbers that are odd. Whatever are the values of number, it does not matter. And two numbers that are even. Can you do something such that all the numbers become even by choosing two numbers of distinct parity and doing some addition operations? Can you do something such that all the numbers at the end become even?
No.
To make all the numbers even, we can only add two odd numbers or two even numbers, but it's clearly mentioned in the question that you can choose two numbers of distinct parity. So it is very much clear that if initially all the numbers are not even, if initially all the numbers are even, so our answer will be 0. We don't need to do any operation, and the parity of the
डिस्कस करेगा तो मैसेज कर देना था
and the we know that we can't sorry. So we know that there are 0 operations needed, and we can like tell that okay, 0 operations are needed, which because all the numbers are initially of the same parity. But if we have something like this, that some numbers are odd, some numbers are even, we can never convert all the numbers to even parity. The only thing that we can do is convert all the numbers to odd parity.
Excuse me, sir.
Yes.
Sir, is it necessary to check whether all the numbers present in the vector are odd or even?
Yes.
Is it necessary? Because
yes, tell.
because we can, when if we apply a for loop in the same direction and we check whether if they are in same parity, we can use if and else statement to add if they are not of same parity, then if they are not of different parity, we can add, or if they are same parity, we will move forward.
Yeah, but how will you do that? Like what you are talking?
Sir,
Like you
I have
have
one
a
doubt.
yes.
Sir, so basically the question states that we need to select the numbers of like different parity. That means that we will select one odd and one even. So that clearly indicates that whatever we're gonna get, so we're gonna get the odd one. So like at the end, the basic goal of our is to make everything odd, na, sir? That's what the
Yes.
clear state. Okay. Yeah.
Yes. So at the end, we will try to make every number odd. Okay.
Hello,
Yes.
sir. Is it okay in Hindi, sir? So can you see the case in like odd number? I guess can you open that question? Just हाँ
Sir, would you
ये
like to do
sir
this, sir?
2 3 sorry ये 3228 like this one 432 yes sir. Here if we want a minimum number to like same priority में change करने के लिए अपन को करना है तो अपन काउंट कर लेंगे इवन जितना होगा उतना ही को अपन चेंज कर पाएंगे ना ऑड बनाने के लिए तो इसका आंसर तो 4 दिए हुए पर 3 ही होगा ना सर.
No. I will make you. Let me explain this test case 43228. Now.
Oops.
43228. So what you will do is first of all you will choose this odd number and this even number. So and wait a minute. Yeah. First of all you will choose this odd number and this even number, and since the
नहीं
smaller of
सर
them.
सर एक मिनट सर मैं क्या कह रहा था ना कि अपन को ये पता करना है कि कैसे चेंज करेंगे कि सारे ऑड बन जाए है ना. तो
Yes.
हम मेरा लॉजिक ये था सर कि जितने इवन होगा वो हम काउंट कर लेंगे ठीक है और मिनिमम और इवन काउंट कर लेंगे और ऑड काउंट कर लेंगे जो हम देखेंगे कि मैक्सिमम कौन सा है लाइक इवन जितना है उतना ही अपन को मतलब बदलना होगा तो इसके कारण पूरा मेरे हमारा इवन हो जाए ऑड हो जाए सर. हाँ तो मैं वही कर रहा था पर यही टेस्ट फंस जा रहा था सर.
It is wrong now. I am explaining why.
ओके
Just listen. So
Excuse me, sir. Sir, sorry for disturbing, sir, but will we discuss D?
no, we will
Problem
not.
D?
No.
Okay.
So we are at 3 currently. So what I choose is I choose 3 and 8. So what will happen is like there are two options. Either I choose 3 and 2, either I choose 3 and 8. Let me discuss both. If I let's suppose choose 3 and 2. So if I do so, what will happen is that the smaller of them is 2. So 2 will get changed to 3 plus 2, that is 5. So now the numbers will become 3, 5, 5, 8 after one operation. Isn't it? This will happen. Isn't it? Now what I will do? Now I have, okay, this is 2, sorry. Now I will do the same with this 2. So now again, the things will change something like this 3, 5, 5, 8 again after plus 1 operation. Okay. Now the only even number is 8 and the odd numbers are 3, 5, 5, 8, 3, 5, 5. So whatever odd number you choose, let's suppose I choose 5. So first of all, what will happen is this 5 will get added by 8. That is, the numbers will become 3, 5, 13, 8 after plus 1 operation. And after that, you will be able to change this 8 to odd number 3, 5, 13, and 21. So if you see, the total number of operations you required are 4, and you were not able to do the same in 3 operations. It's not possible to do the same in 3 operations. Even if you choose the alternate path, that is you choose 3 and 8 first. So again over here, first of all, you need to the value 3, the value 8 will get added, because we have a condition that if we are choosing two numbers of different parity, so the value gets added to the smaller one. So yeah, is it clear now?
Sir,
Yeah.
Sir, can you please explain the intuition one more?
I have
Just,
not
just the
explained
intuition.
intuition till now. I have not explained the intuition till now. Is the question clear?
Okay. Yes, sir. I have. Yes, sir. Clear, sir. The
Okay.
question is clear.
See, so now the intuition would be that, okay, if we have all numbers as even and all numbers are odd, we don't have a problem in that. But what if there are some numbers odd and there are some numbers even? Some conclusion that we have already reached is that at the end, we are going to make each and every number odd. That is some conclusion that we have reached. So let's suppose I tell you that I have 3 numbers that are even and there are some numbers that are odd. Okay. So now let me take some values. Let me take that the even numbers are 2, 4, and 6, and odd numbers are 1, 1, and 1. Let's suppose we have these 3 odd numbers and these 3 even numbers. Now just try to think one thing. Let me make one more change over here. 1, 2, 4. Let me explain with 2 examples. The first example I will take is 1, 2, 4, 6. And second example that I will take is 1, 1, 3, 2, 4, 6. Okay, I will explain with these 2 examples. 1, 1, 2, 4, 6. First, let's explain via this. You have 1, 1, 2, 4, 6. So what you will do now? You have an odd number and you will change every even number with an odd number. So what you will do? If you choose this odd numbers with any of the even numbers, are you able to observe one thing, that the first operation will not convert even to odd. In the first operation, odd will get added by some even number. Are you all able to observe that thing?
Yes, sir.
That
Yes,
during
sir.
the first operation, it will something that will happen. Now
Yes.
there are 2 possibilities for me. Either I choose 2 or I choose 6. I will never choose 4. Now, why I am telling something like this? This is because if I, let's suppose, choose 6. So if I choose 6, so what will happen? This 1 will get added by 6, that is 7. And after that, this 6 will get added by 7 and its 6 will get converted to 13. So after 2 operations, this 6 will get converted to 13. And once it happens, I can by guarantee and by sure, I can say that for all the remaining even numbers, I will need only one operation. For 4 also, I will require only one operation. For 2 also, I will require only one operation. Are you all able to relate by that? Because
Yes, sir.
whatever
Yes.
odd number we get
Yes.
now will
Hello.
definitely be greater than the remaining even numbers that we have. Isn't
Sir,
it?
could you please
Yes.
explain the intuition one more time?
I am telling that you have the odd number, you have numbers something like this 1, 1, 2, 4, 6. Now I know that by using the odd number, I need to add this odd number to some of these even numbers to these even numbers and convert them to odd. But looking at the numbers, I can definitely say that the first operation when I do with 1, the numbers will not get added to even numbers. Instead of that, in my first operation, my odd number will get incremented. After that, I will add that particular number to my even number, isn't it? So what I choose is, let's suppose I choose 6. If I choose 6, so what will happen is this 1 will first of all get converted to 7. And after that, by using 7, this 7 will remain 7 as it is. And this 6 will get converted to 30. That is 7 plus 6. Now, once that happens, I can definitely guarantee you all, and you all can think of it as well, that whatever remaining even numbers we have, for every even number, we will require only one operation. Because I have one odd number with that is very big number, and since I chose the biggest even number, so I can definitely say that whatever remaining even numbers I have, they will definitely be lesser than this particular odd number. And so for every even number, I would require one operation, and my job will be done in 2 plus 1 plus 1, that is in total of 4 operations. Can I say this?
Yes, sir.
But there
Yes.
can be the case something like this as well, that 1, 1, 3, let's suppose 1, 1, 3, 2, 1, 1. If this is, sorry, 2, 2, 2. Let's suppose this is the case. So now in this, you would require only 3 operations, right? This 3 will increment 2 and make it 5. Then 5 will increment 2, make it 7. 7 will increment 2, make it 9. So in this case, you require only 3 operations, isn't it? And there can be the case something like this as well, that you have something like this. The odd number is 3. If the first even number is 2, the next even number is 6, and the next even number is 8. In this case, for converting first even number, you require only one operation. It will get converted to 5. But for converting rest of the even numbers, you require at least one of the numbers. For at least one of the numbers, you will require 2 operations. Either you choose 6 or 8, you will require 2 operations for at least one of the numbers. So let's suppose I choose 8. So my 5 will get converted to 13 first. After that, my 8 will get converted to 13 plus 8. That is 21. And now by using 21, I can definitely convert 6 to an odd number. So the conclusion I am able to draw is that, okay, if I simply short my even numbers, so there are two possibilities, that if I have an odd number, so I simply start converting from here, or I start converting from here. Whatever minimum answer I get from these two possibilities will be my answer. That's the only thing that you need to do. Simply short the even number, take the maximum odd number, because what is the best, when you will get the best case scenario? The best case scenario will be when you choose the maximum odd number. Why? Because if let's suppose you have something like this, that 2, 2, 2, and you have two odd numbers, 1 and 3. Now, if you decide to choose one, so see, for converting 2 to an odd number, you will require two operations. But if you choose 3, in that case, you will require only one operation. So the best case scenario is when you choose an odd number with maximum value and then try to convert the even numbers. Now there are two possibilities. While converting the even numbers, you either start converting even numbers from their lower value to their higher value, or from their higher value to their lower value. Whatever answer you get from that, let's suppose from lower to higher you get answer 1, and from higher to lower you get answer 2. So your answer will be minimum of answer 1, answer 2.
Excuse me, sir. Can you please repeat? Because due to some disturbance, actually, not
Which part you didn't understand?
this part, like the answer one and answer two.
Okay, I am
Rest
telling
everything I
it,
understand.
if you let's suppose short the even numbers in ascending order, so there are two possibilities you have. You either start converting from the lower value to the higher value, because why you are deciding to start converting from lower value to higher value? This is because this possibility exists that you have 3, you have 2 over here, you have 4 over here, you have 6 over here. Now, if you start converting from lower value to higher value, see, you will get the minimum answer, because this 2 will first of all get converted to 5, then this 4 will get converted to 5 plus 4, 9, and then this 6 will get converted to 9 plus 6, that is 15, and in 3 operations the job was done. But if you would have decided to convert from higher to lower, then to convert 6 to an odd number, since 3 is smaller than 6, you would have required 2 operations. So first of all, this 3 would have changed to 9, and then this 6 would have changed to 9 plus 16, 15. And then for the rest of the even numbers, you would have required one operation. So in that case, the total operations you would have required is 4. So you can see that when you started converting from lower to higher, you were able to achieve the minimum number. But there can be cases where if you start to convert from lower to higher, in that case you will get a bigger number in comparison to smaller one. Like for example, if I just generate a case something like this, you have the odd number as you have the even number as 3, you have the odd number as 3, even number as 4, then even number as 8, and then even number as 60, something like this. Now just try converting from lower to higher. So first of all, if you try to convert 4 from 3, so let's not do that. Wait a minute. So it will be 8 and 3. Let us take this 12. Okay. So now if you try converting from lower to higher, so first of all, you will try to convert 4 via 3. So you will require 2 operations. So what will happen? First of all, this 3 will get changed to 7, that is 3 plus 4. And then this 4 will get changed to 7 plus 4, that is 11. Once that happens, you have used 2 operations. Now again to convert 12. You will require 2 operations again. Isn't it? You will require 2 operations again. So what will happen? First of all, this 11 will get changed to 23, and then this 12 will get changed to 35. 23 plus 2.
Recording will be shared or not?
Yeah, it will be shared.
Okay.
Then now you can convert 60 by one operation, and the total operations you would require is 5. But in this case, you were too wise to decide from higher to lower. In that case, if you observe, just wait a minute. Yeah, in this case, if you observe, so first of all, you will change this odd number will get changed to 16 plus 3, that is 19, and then this 16 will get changed to 19 plus 16, that is 35. So you have used 2 operations. Now for converting the remaining even numbers to odd, you will require 1 plus 1 operation. So in total 4 operations, your job will be done. So if you started from higher to lower, you were able to do the things in 4 operations, but if you started from lower to higher, you were able to do the job in 5 operations. So in this case, you got the minimum answer when you started from higher to lower, but in the other case, you got the minimum answer when you started from lower to higher.
Excuse me, sir.
Yes.
So first, in this case, we have to identify the point where the first odd number is coming, right?
No, we can simply short. You are allowed to choose any indices. So you can take the maximum of all the odd numbers available to you.
Okay. At the first, we'll find out the max of the odd number.
Yes, I am talking about the implementation, but the logic should be clear.
Okay, sir.
Sir, but
Okay,
then
so
there is one thing.
yeah,
So like when you made like there will be two cases like we start like जैसे दो 2 4 6 दे रखा है तो जैसे starting में हम 2 4 6 से जाए last वाले example में you explained that we started from 16. Sir, won't we do like we make two cases that we first traverse from left to right, then from left to right, and then take the minimum of all? That would give our
yeah,
answers.
that only I was talking, no?
Yeah, like we have to do two iterations then.
Yes. So let me jump to the implementation part then. So first of all, took the input of n, then took the input of vector, then initialize my count 1 to 0. So basically, I am counting the total number of odd numbers. So I iterated over the vector. If my number is odd, I simply incremented my count. So if my number of odd numbers are 0 or n, so I know that in that case, my answer will be 0 since all the numbers are of same parity. So I will simply print 0 and return. Otherwise, I made two vectors, vector v1 and v2. v1 is going to store all odd numbers and v2 is going to store all even numbers. So I iterated over the numbers. If the number is odd, so in my v1 I pushed back the number, else in my v2 I pushed back my number. Then it was not necessary for you to construct these two vectors. If it was enough if you construct only the vector of even numbers, but during the contest I wrote something like this. So this code looks like this. So I am explaining what is written on the screen. So I simply sorted both these vectors in ascending order. And I know since I am going to choose the maximum odd number, I am going to start with maximum odd number. So the maximum odd number will be the last element of this vector v1. And initialize my answer to 0. That is the number of operations I required is 0. So in first case, what I did is I started traversing from left to right. And that is stored in my answer. So I iterated over vector v2. v2 is storing all the even numbers. So if my current maximum odd number is lesser than the even number that I am, if you just look up, if this is something like this, that my odd number is 3 and my even number is, let's suppose, 4. So what will be the final value of the maximum odd number that we will get? So first of all, with this 3 will get changed to 7, and then this 4 will get changed to 7 plus 4, that is 11.
11.
So actually this value of 4 is changed to 4 into 2 plus the odd number that we were having. Isn't it? Because 4 get added over here as well, 4 get added over here as well, and 3 got added once. So I can say that my if my current maximum odd number is lesser than the even number that I am, in that case the number of operations I would require is 2, and my temp will change to the current even number multiplied by 2 plus the current odd number. Else, if this is not the case, my answer will simply increment my 1. I only need one operation, and my maximum odd number will change to odd number plus even number. Once I'm done with this, so this is when I iterated from left to right. The same thing, completely the same thing I did for right to left as well. So I simply reversed my sorted vector v2, so it becomes reverse sorted. Again started with temp as v1 dot back, initialized my answer 1 to 0, and did exactly the same thing. That is, so this basically makes a traversion from right to left. Once I am done with this, I simply printed minimum of answer 1 and answer 2, and you are good to go.
Sir, you were saying that we do not need to create the odd numbers vectors because we can find out first the biggest of the odd number and do the
Yeah,
same.
we can do that. Yeah, we can find the biggest of the maximum. We can find the maximum odd number directly.
Okay, sir.
The codes will be shared in the description of the YouTube link, so that's not an issue. Okay.
Sir, I have a doubt here.
Yes.
So, sir, I have a doubt.
What I
Yes.
implemented was I had a priority queue, uh, which had the minimum element of even element, right? And I took
Okay.
the highest odd element, and I
Okay.
did the same thing like if the sum of the current sum is less than the even element, then we will increment our count by 1 and we'll do the sum plus even element,
Okay.
right? But if the even element is greater than the current sum, then we will increment the count by 2 and increment the sum by 2 times the even element.
Okay.
But it was giving TLE. Then what I did, I observed that in the second case, the answer always would be the total number of even elements plus 1. So that ran fine, but that was giving TLE. Why?
That I need to look up to your implementation actually, why it was giving TLE.
So,
Yes.
sir, I have done the same way that you told. No, I have created two vectors. One is even, one is odd. Then I sorted both vectors. Then I implemented multiple conditions for fast execution. Means if if our last element of odd vector is greater than the last element of even vector, then I have directly print number of element in even is answer.
Okay.
Else then I have continued that case. Means after printing the side I have continued, and in else section I have wrote taken an input HO, that is highest odd number.
Okay.
And in answer now I have also created on the code is in sir chat present. If you want to look up for that, that's in chat. And I have created,
Actually, if I
I
look
have
up to your
created an integer.
implementation, it would like take a long time. So have you enrolled in batch of TLE?
Yes,
You
sir.
guys are enrolled, right? So you have the doubt section.
TLE
So over there you can
1
raise your
want to.
yeah. So over there you can raise the doubt and the mentors will help you out with the discussion. Okay.
Okay, sir.
Yes,
Thank
sir,
you.
I have a question, sir.
So if you have the problem in implementation, so you can just clarify with mentors about your implementation. The logic should be clear. Yeah. Go ahead with the
Sir, I
question.
have a logic doubt, sir. Doubt in logic.
Yes. Yes.
Basically, we are going to convert the even parity into odd parity in all the
Yes.
cases. Are we
Yes.
correct, sir?
Yes.
Are we correct, sir? If there is a combination of both the even and odd number in an array, we are trying to convert all them into odd parity bits.
Yes. Yes.
Okay, sir. Yes, sir, that's what the intuition. Okay, sir.
Yeah, because you can't convert all them to even, isn't it? Because to convert to
Sir,
even, you have to add two odd numbers and two even numbers. But it's given to you that you can't add two numbers of same parity. You can't take two numbers of same parity. So how will you convert
yes,
all
sir, I
them to even?
understood. Can you please explain with one test case? Why can't we you convert them into even parity? That I have a doubt, sir, in that.
If I let's suppose have numbers like this, 3, 2, 4, okay, and I want to convert this 3 to an even number, like let's suppose you have one more odd number 5. I want to convert all them to even. How will you do? What you will add to 3 so that it gets converted to even? To convert this odd to even, odd plus something equals to even, what number you need to add over here?
I
What should be
think
the
we need to
parity?
add an odd number.
We need to add an odd number, but it's clearly mentioned in the question that if you are choosing two indices I and j, and you are doing
Yes, sir.
something like this, ai equals to ai plus aj, or aj equals to ai plus aj, if something like this is happening, so these two numbers, ai and aj, should be of different parity. So you would never be able to add two odd numbers.
Yes, sir, I
Isn't it?
understood, sir.
Yeah. So now let's jump on to the third question. So wait a minute. Yeah. So the name of the question is light switches. So there is an apartment consisting of n rooms, each with its light initially turned off. So to control the lights in these rooms, the owner of the apartment decided to install chips in the rooms so that each room has exactly one chip and the chips are installed at different times. Specifically, these times are represented by the array A1, A2 up till AN, where AI is the time at which a chip is installed in the ith room. So as soon as the chip is installed, so first of all, you understand these para. It's written over here that you have n rooms. Initially, all lights are turned off. Now there is a person who is installing chips in the room. In the first room, he is installing chip at time AI. In the second room at time A2. in the third room at time A3, so on up till n room, he is installing chip at that particular time in the ith room. At AI time, he is installing the chip in the ith room. Now, as soon as the chip is installed, some value k is given to you. So what happens is it changes the room's light status every k minutes. That is, it turns on the light for k minutes, then turns it off for next k minutes, then turns it back on the next k minutes, and so on. Like it's switching for every k minutes. Like for example, if the chip was installed at minute AI, so lights will get turned on at AI, it will get turned off at AI plus k, it will again get turned on at AI plus 2k, get turned off at AI plus 3k, and so on. So the question is that what is the earliest moment when all the rooms in the apartment have their lights turned on? So this is the question for you. Do anyone have any difficulty in understanding the question? And it is also given that if such minute exists, so in that case, just print that particular moment, the first moment when every light is turned on. Else, if no such moment exists, simply print -1. Do anyone have confusion in understanding the question? Okay, so how to solve this? So just imagine one thing. Okay, if I let's suppose have a light that is, let's suppose I have a chip that is installed at minute 2. I have a chip that is installed at minute 4. Let me form some good example. And I have a chip that is installed at minute, let's suppose 7. Okay. And let's suppose the value of k is 2. So can I say that from 2 to 3, light 1 will be on. From 4 to 5, it will be off. From 6 to 8, it will be on. And from, this is I'm talking of first chip, first room. And from 9 to 10, it will be off. Can I say this? On, off, on, off. Can I say this? Okay. Similarly, talking for the second one. Can I say that it will be on from 5 to 7, off from 8 to 9? Okay, sorry. Yeah, it will be on from 5 to 6. It will be off from 7 to 8, on from 9 to 10, something like this. So on, off, on. Similarly, for the third one, it will be on from 7 to 9 and off from 7 to 8 and off from 9 to 10. Now, just understand what claim I am making. I am making a claim that if there is a situation where every bulb is turned on, it will occur, then it will be turned on for the first time in the range 7 to 8. Let me repeat. I make a claim that if there is a condition such that there is a time exists such that every bulb is turned on at that particular time, so that time will be in the range 7 to 8. Why I am saying something like this? Because try to imagine every bulb have the same what I would say same pattern of getting switched off and switched on at every interval k. So when there is a last chip, that is when the last chip the chip in the last room turns the light in this particular room on, so it is turned from 7 to 8. So every time what happens is, let's suppose something like this is happening, that for the last room the light is turned on from 7 to 8. This is I am talking for the last room. And there is one room for which the light was turned on till 6. The light was turned on till 6. So can I say if the light was turned on till 6, so again it will get turned on at 9. Can I say this? if there is a room for which the light was last turned on at 6, so again it will get turned at 9, get turned on at 9. Similarly, if this is the case, can I say it will, once it get turns on at 9, so at that, so it will remain turned on for minute 9 and minute 10. But the time at which it is turned on, this particular room will be turned off. For this particular room, the lights will be turned off. And for this particular room, the lights will get turned on at 11. But again, then for this particular room, the lights will be turned off at that particular time. So if I am, since I want that at a particular minute, every room has the lights turned on, so this will not be the case then. So then there can be the case something like this as well, that let's suppose you have something like this. There is a room that in which the chips get installed at 7, and I know that since the value of k is 2, so the lights will be turned on at minute 7 and minute 8 for this particular room. Now there can be a room for which the light was last turned on till 7. That is, it was turned at 6 and 7. And there is a room for which the light was turned off at 6 and 7, but gets turning on at 8. That is, at 6 and 7 it was off. That is, it was last turned on at 5. Now it was off at 6 and 7, but again got turned on at 8. So can I say that these two rooms will never have a moment such that the lights are turned on at the same time? Can I say this? So that's the reason I make a claim that if there is a possibility, since I need to find the minimum time at which the lights of all the rooms are turned on. So if that is the case, so it will always exist in this range. That is the maximum value of AI, that is the maximum time at which for a room a chip was installed, plus the value of k minus 1, that is 7 plus 2 minus 1, that is 8. So from 7 to 8, we will have a time at which for every room the light is turned on. Otherwise, if we don't find any time from 7 to 8 for which the light is turned on, I will simply return minus 1. Once you are able to understand this, so the second thing that you all need to understand is that if I let's suppose tell you that the value of AI is 2, that is for a particular room the chip got installed at time 2, and the value of k is 4. And I give you some random time, let's suppose 13, and I ask you that at this particular point of time, just tell me, will the lights will be on or off for this particular room? How will you do that? How will you check that whether the lights will be turned on or turned off for this particular room at time equals to 13? Because I know that since the value of AI is 2 and the value of k is 4, so the lights will be turned on from 2 to 5. Then it will be off from 6 to 9. Then it will be on from 10 to 14. So I can see that at 13 the lights were on. So how I can calculate that? So what you need to do is you need to simply calculate the time that I ask you, that is 13, minus the turn on time, that is 2, divided by the value of k. The value of k is 4. So if this turns out to be even, so I can definitely say that the lights will be turned on. So I can say that if there is any general time t, so the lights will be turned on if t minus ai by k is even. Yeah, I can prove it. See, for being turned on, what should be the case? We have case something like this, that wait a minute. Can you prove it should be in the range? Yeah, I proved it that it should be in the range, right?
Sir, can you do it rather this formula for the given test cases?
Sorry, can you repeat?
Sir, can you please do the dry run for the given test cases with this formula? That will give more clarity.
Which formula are you talking about?
Sir, this time minus AI upon P.
Yeah, I can. See. So let's suppose I already did that, no? Like if I let's suppose tell you the value of AI is 2, the value of AI is 2, and the value of K is 4. So the lights will be turned on from 2 to 5, it will be turned off from 6 to 9, and it will be turned on from 10 to 14. So if I give you a random time 13, so if you simply calculate 13 minus 2 by 4, what you will get? You will get value 2, which is even. So you can observe that at time 30, the lights were turned on. This value will be
Sir, we
actually
can say
13.
that every alternate even number, the light will be turned on.
Alternate even numbers, what do you mean by that?
So like 10 to 13, the light will be on. 10 to 14, the light will be on. Next,
No,
it will
10 to
be off.
13 it will be on. 10 to 13
Yes,
it
sir.
will be on.
It will be on. Next, it will be off. After that, it
Yes.
will be on. Yeah, that
Yes.
means at 2 it will be on, 3 it will be off, but at 4 it will be on.
So can you repeat, please? I just missed it. From
So like 17, now in the next interval, the light will be on.
yes. So
So every alternate even number like 0 here 0, then 2, then 4, the light will be on, and all for the odd number it will be off.
like over here it is forming pattern something like that because some specific values of AI and K. But to generalize for any T that what will be that whether the light will be turned on or off, you can directly use this formula. That if T
Okay, sir.
minus AI by K is even, then the light will be turned on, else it will be turned off. Because at every time T, yes,
Yes, yes, sir.
because what is happening? That's something like this. You have AI, and at some, like let's suppose at 2K, from 2K to from AI plus 2K to AI plus 3K, the lights will be turned on. From AI plus 3K minus 1 till here, the lights will be turned on, right? So if I simply divide it by K, I know that there are intervals like in first K. In first K intervals, the light will be turned on. In the second K, the lights will be turned off. In third K, the light will be turned on again, something like this. So if I am dividing by K and I am getting 2, like let's suppose I am getting 2, this means that I am in the third interval, right? If I divide by K and if I just subtract these two values and divide by K and I get value 2, let's suppose. So this means that I am in the third interval. So I know that in the first interval, my lights will be turned on. In third interval, my lights will be turned on. In fifth interval, my lights will be turned on. I know that. So if I simply subtract these values and divide it by K and I am getting an even value, this means that the lights are turned on because this means that I am in the odd interval.
Hello.
Whatever equation we wrote, it is mostly by trial and error, no?
By not definitely by try and error. Yeah, during the contest, I figured it out by try and error. But if I try to explain it, then it's not like that. Because just try to think, you have some K value first, then you have K value first, then you have some K's value, then you have some K values. Okay. So if you simply subtract this value and this value, so how many times you will get, like if you subtract this value and if you divide it by K, what is the value you will get? You will get 2, na? Because
Yes.
2 Ks are completed. So if you are at an odd interval, and if you take any value from this odd interval and subtract it with initial value and divide it by K, you will definitely get an even number. Because by that particular point of time, 2 Ks would have been completed. Similarly, if you are over here, you are at the starting of this fourth interval, and you simply now subtract these two values and divide it by K, you will get an odd number because there are 3 Ks that are completed. So in that case, you can say that the light will be turned off at that particular case.
Okay.
Isn't it?
Sir,
So
can
it's
you
not trial and error. Yes.
sir, can you take 3 slides back?
3 slides. Wait, 1, 2, 3.
Yes, sir. Here, ahead. One slide ahead.
Here. Okay.
Yes, sir. Here, sir. Can we say like I have a little confusion here. Can we say like that the all the lights will be turned on? Uh, so for all the lights to being turned on, we have to take the highest value into consideration because after that, if the minimum value and the highest value, If the first interval of the minimum value comes under the interval of the highest value, then we can think about it.
So do you agree with this that the lights will be, if lights will be turned on, so
Yes, sir.
and if there is a case, so it will be in the range 7 to 8. Do you agree with this?
Yes, sir.
Once you are good to go with that, I don't have any problem. Okay. So now once you understand that okay, so once you understand all these things, now let's come how to solve the question. Well, still now we haven't even stepped into how to solve the question. So there now the next thing that will come to your mind is that okay, I know the range. I know the range that in which the lights will be turned on. So why not do one thing? Go to each and every point. Go to each and every point and just check for all the lights whether they will be turned on at that particular point or not. And the minimum value that we get that the lights will be turned on at that particular case, we will simply return that as our answer. That particular minute as our answer. And if it is not so, we will return -1. If we don't find any point in this range, we will return -1. But wouldn't it produce TLE? Because the value of k given to you is of the range of 1e5. So you have some maximum value of AI and you are checking from AI to AI plus k -1, isn't it? So these values is of the order of k, and I am telling you to check for every point for all the n rooms. So wouldn't it take you the complexity of k into n? And since both are of order of 10 power 5, so you would definitely get TLE over here. So you can't do something like that. So what you need to do is, so if let's suppose I say you this is the maximum value of AI and this is the last value of AI, this is AI plus k -1, I know that if my answer exists, it will exist somewhere in between. So if I tell you that a light for a particular room, now I am talking for a particular room. How can we calculate that for a particular room where are the points that the lights are turned on? So now for a particular room, if I say you that light was turned on at AI, light was turned on at AI. So what will be the case? If I turned on, I am marking it by true. Okay. So if a light was turned on at AI, so there will be the case something like this. Either it will be turned, if it is turned on at AI, so there will be some parts, there will be some range till where the light is turned on, and then it will become turned off. This will happen. And if light was turned off initially, so it will happen something like this, that light was turned off till some point and then it was turned on. So if for every room I am able to find, if I am able to find that, okay, what is the last, if the light was turned on at this point, if the light was turned on at this point, if I am able to find that what is the last point at which the light was turned on, and if the light was turned off at this point, I am able to find what is the first point at which the light becomes turned on, if I am able to find that. So just imagine what we will be able to achieve. Let's suppose there was a light that was turned on from here to here, and there was a light that got turned on at this particular point, and then it was turned on till here. So can I say that at this particular point, both the lights are turned on? Isn't it? But if I let's suppose have a light that got turned on at this particular place and then it was turned on for the remaining range. So can I say that in this case my answer will be -1 because this particular light was turned on from some point till this point, but this particular in this particular room the lights became getting turned on from this particular point. So they will never intersect. So this is how you can solve this question. What you can do is for every light that was turned on at start, you can find the minimum value up till which they will get turned on. Like if there is a light that was turned on till this particular point, there was a light which was turned on till this particular point, there was a light which was turned on till this particular point. So you will calculate this particular point because till this particular point from the start, you are assured that all the lights that were turned on at the start will remain turned on. And for all the lights that were turned off at the start, you will find the maximum point at which they started getting turned on. So if let's suppose there was a light that started getting turned on from this point, there was a light that got started getting turned on from this point, and there was a light that got started getting turned on at this point. So you will calculate this point. That is maximum of all the points. So now, if the maximum of all the points is lesser than this value, is greater than this value, can I say that the answer will be -1? Because there will not be any range for which the lights were turned on. But if this is not so, so I can return this particular value. That okay, whatever this value is, I know from that particular point the lights have got all the lights have got turned on, and since this particular value, like this is the case, there is a light that is getting turned on from this point to this point. There is a light that has been turned on from this point to this point. There is a light that is turned on from this point to this point. Okay, so this is your starting point. Actually, this is your maximum value of AI. So this is your starting point. So you know at max these lights will be turned on till this. Now, similarly, there were some lights that started that were off at this particular point, but getting started turned on at some value. So let's suppose there was a light that started getting turned on over here. There was a light that getting started turned on over here. It was turned on then afterwards, and there was a light that got started getting turned on from here. So can I say that if I return this particular value, so at this particular value, every light is turned on? So how do I find this value? This value can be found out by taking maximum of all these points. If you take maximum of all these points, let's suppose this value is 4, this value is 6, and this value is 5. So maximum of all these points is 6. Similarly, for let's suppose these values are 8, 10, and 9. So minimum of all these values is 8. Now, since 6 is lesser than equals to 8, this means that there exists a point at which all the lights are turned on. So I can simply return 6. But if this was not the case, if the case was something like this, that there was a light that was getting turned on at this particular point, that is at point 4, but there was a light that was getting turned on at, let's suppose, 9. So in this case, if you just take maximum of 4 and 9, you will get 9, and the minimum of 8, 9, 10 is 8. So since 8 is lesser than 9, so you will simply return -1, because you can see that this particular light was only turned on till 8, but this particular light got started turning on at 9. So in this case, your answer will be -1. By the logic that if we have a point, at which all the lights are turned on, then it will definitely exist between AI to AI plus k minus 1. So this is the logic to this question. If anyone is not able to understand any of these things, so once the recording gets uploaded, you can just go through that once again, because it may take time for you to understand. First of all, try to understand this logic, AI to AI plus k minus 1. Once you are able to understand that logic, try to figure out this formula, t minus AI by k1. Once you are able to do that, then just see that if directly we do for each and every point, we will get TLE, that is the complexity of k into n. Once that is done, so then think of interval part. Once you are able to understand that, then you will good to go. So let me jump on to the code. Yeah, interval represents true, that is every bulb is turned on. So what I did is I took the inputs of n and k, took the input of vector v, shorted my vector. So it's your choice. You can either short or not. Then I took the maximum value. Since I wanted the maximum value of v, I took the v dot back in my starting index. Because I know that my lights will be turned on. You can neglect this line. You can ignore this line. It's not needed. So I initialized my maxi to v dot back. That is this value. I know that this value, this bulb AI is turned on from AI to AI plus k minus 1, isn't it? I have this line initially. So since I want to take the maximum of all these values, so I am initializing this value with v dot back, that is the minimum possible value. And since I want to take the minimum of all these values, so I am initializing this value with si plus k. V dot back plus k minus 1. Okay. Now I went to each and every bulb, initialized. Now how will I find this one, this thing, this interval, true, this interval, how will I find last true or first true? How will I find this? Using binary search. It's the very common problem of binary search on answer. So by using binary search, you will either get this last true or this first true point. So initialized my starting index to v dot back, ending index to starting index plus k, and answer some answer variable. Now there are two cases I know, that initially at point at point v dot back, that is at point ai, my light is turned on or turned off. There are two cases. So I handle those two cases differently. If v dot back minus vi by k is odd, what does this mean? This means that the light is turned off at this particular point vi. So we shifted our binary search element, something like that. So while starting index less than equals to ending index, we found out mid. If mid minus vi by k is odd, if mid minus ai by k is odd, so this means that we are initially in these intervals. So we know that our since we require the first true, so we simply shift our starting index in that case. We simply shift our starting index. Else, if this was not odd, this was even, this means that we are somewhere over here. So that is one of the possible answers. So in that case, we will assign our answer to mid. And for in search of the better answer, since we are standing somewhere over here, let's suppose, and we want the first true, so we should shift leftwards in search of the better answer. This is what actually we do in binary search on answer, isn't it? So we initialize our answer to mid and shifted our ending index to mid minus 1. At the end, we know that since we need to find the maximum of all these values, so in my maxi variable, I simply did max of maxi comma answer. And exactly the opposite in case if the light was initially turned on at v dot back, that is at maximum value of ai. So in that case, I know I will have my binary search predicate monotonic function returning something like this: true, 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 false, false, false. So if I am getting true for some value of mid, I will initialize my answer with that, and simply in search of better answer, I will shift towards right. So what I am doing, while starting index less than equals to ending index, mid is starting index plus ending index by 2. If mid minus vi by k is odd, this means that this can't be our answer, and our answer, if exists, will be on the left hand side. So shifted our ending index to mid minus 1. Else, that can be our possible answer, but if some better answer exists on the right, so in search of that, we will simply shift our starting index to mid plus 1. And since we know that we want to take the minimum of all these points, so in our mini variable, we did simply mean of mini comma whatever answer we are getting. At the end, if the maxi value is less than equals to mini value, so we are good enough to print this maxi value and return. Else, we know that our answer will be minus 1. And yeah, that's all. So yeah, this is a binary search problem actually. It's not a direct problem. Not a direct problem of binary search as well, but yeah, if you look, the most of the code part is binary search only, so we can say that it's a problem of binary search. I don't know if some other solution for this exists. I coded it down like this during my contest. So that's all
Bhaiya,
from, yes.
how do we handle the constraints given in the problem?
Like, what do you mean by that?
Like in the problem B, we had constraint of executing in 1 second, and
Yes.
as of I know, it takes 10 to the power 8 seconds for one iteration.
Yeah, so if you are given something like this, like 1 milliseconds, 2 milliseconds, something like 1 second, 2 seconds, something like that, for all you will like 2 seconds, 3 seconds are from some problems. Like let's suppose it's taking a time complexity of 2 into 10 power 8. Like if 10 power 8 complexity takes you time 1 second, so 2 into 10 power 8 will take you time 2 seconds. So it does not change much, isn't it? If you are able to code it, because it happens sometimes that question is like that, that whatever complexity it is coming, it is taking 2 into 10 power 8 instead of 10 power 8. So that's the reason they mentioned 2 seconds over there. So that is something that you should not look for. You should always try to solve the question in like within 10 power 8. If it is taking 2 into 10 power 8, they would definitely give you time of 2 seconds over there. Okay.
So, Bhaiya, how
Yeah.
to look for the optimal approach for a question? Like the question problem B, I was using a two-pointer approach. So that was giving a time limit execution
Yeah,
error.
that will come by practice only. That is the only thing I can say. There is no hard and fast rule that
Okay,
you can
okay,
use
Bhaiya.
that, and yeah.
Sir, can we ask doubt on the doubt section of TLE website where it's given resolve doubt?
You can ask doubt from now on. No? It's actually activated as of I know.
Because our Discord is like posing a problem because on phone it's like not getting downloaded and on laptop it's like some silent issue is coming which is not being fixed since 2 days.
Discord is the only medium via which you can ask the doubt. So in that case, you should definitely contact managers. You should text them so that they will help you out via coming in Meet, and they will help you to install Discord or something.
Also, we have one more thing.
Yes.
In today's recursion problem solving session of level 2,
Yes.
could you once more clarify when to use recursion for a problem to solve? Like I was trying.
When you want to explore all the different possibilities, when you have different possibilities with you, and you want to explore all the different possibilities, you use recursion.
So like at today's contest, I was trying to solve problem B using recursion, but I wasn't getting anywhere. So was it possible to solve that problem using recursion or?
Problem B using recursion. How you were trying it? Like you were trying to convert even numbers to odd numbers, right?
Yes, yes, yes.
So you will decide that, okay, no, that is not possible using recursion. That is possible, but it would take a lot of time.
Okay, okay. So when, okay, so that would come again with practice. Okay. Yeah. Okay. Thank you, Veer.
Okay, bye everyone.